Network topology refers to the arrangement of various elements, links, nodes, etc., in a computer network. It essentially outlines how different devices on a network are interconnected. So let's talk about some common examples. The simplest topology is point-to-point topology. In this configuration, there is a direct connection between two nodes, allowing one-to-one unicast communication between those nodes. It is extremely straightforward to set up, requiring minimal hardware and configuration. Since the connection is dedicated to only two nodes, the full bandwidth of the connection is fully available to these nodes. In modern networking, point-to-point connections form many of the direct data links between adjacent nodes that are underlying more complex network topologies. The term point-to-point as a distinct topology is often loosely applied, but generally refers to a network that has only two nodes and a direct data link between them, for example, a computer connected to a printer. One of the most basic and widely understood topologies is the bus topology. In this setup, each computer or network device is connected to a single central cable referred to as the bus. This topology is simple, cost-effective, and relatively easy to install. Data is sent over the central bus and is received by all devices. However, only the device for which the data is intended processes it. Extending the network is as simple as connecting a new device to the existing bus cable. The bus topology is simple, but it does have its disadvantages. For one, it can suffer from a single point of failure. If the central cable fails, perhaps due to a breakage or severe attenuation of the signal, then the entire network will be disrupted. Additionally, as more devices are added, the amount of traffic increases, leading to potential data collisions and generally reduced performance. Next, we will look at the star topology. Star topology is one of the most common network topologies used in local area networks. In this setup, peripheral nodes in the network are connected via a central node, such as a hub, switch, or router. This central node sends data to and from the various devices that are connected to it. This type of network is highly dependent on the central node. Adding or removing devices is relatively easy and does not disrupt traffic for the rest of the network. This is because each device is independently connected to the central node. Since devices are independently connected, it is easy to detect and troubleshoot faulty devices or connections. The performance of a star network is generally high, as there is a direct path between any device and the central node. However, the speed and quality of the network depend largely on the capacity of the central node. The star topology can be easily scaled up, as more nodes can be added easily without significantly affecting the network's performance. One potential problem with this topology is that if the central hub, switch, or router fails, then the entire network will go down. Additionally, the central node device can be expensive, and this topology requires more cable than a bus topology because each device on the network must be individually connected to the central node. Star topology is widely used in home and office networks. It's particularly common in situations where reliability, performance, and local area scalability are important. Next, we will look at ring topology. In ring topology, each device is connected to exactly two other devices, forming a closed loop. Data travels in one direction through the loop and passes through each device until it reaches its destination. The ring topology is relatively simple to install and set up, requiring only enough cabling to connect each device to its two neighbors. The unidirectional flow of data reduces the chance of data collisions. One disadvantage of this type of network is that if a single connection is broken, then the entire network goes down. Additionally, adding new devices disrupts the entire network. Further, as more devices are added to the ring, the longer it takes for data to travel through the network, which can impact performance. In modern network design, ring topology may be integrated into more complex network structures, rather than being used as a standalone solution. For instance, it might be a component in a network that combines elements of star, ring, and other topologies to optimize performance and reliability.